So 7A, 660 nanometer monochromatic light is incident on a thin film. Okay, kita kenakan cahaya atas satu filem nipis. The refractive index is 1.35. Calculate the minimum thickness of the film which produce disruptive interference of the reflected light in the following situation. The thin film, we put it in A. Kita letakkan thin film tu dalam udara. Second one, the film is coating on a glass of refractive index 1.5. Okay, so kita ada soalan thin film. Kalau you ingat lagi apa teacher beritahu you, bila you jumpa soalan thin film, pertama you visualize dulu your thin film. Okay, then you tanya diri any phase change for the reflected ray. So kita kena pasti dulu any phase change for reflected ray. Third one, then kita identify our source is in phase or anti-phase. Okay. Then kita identify keywords daripada keywords in the question. Kita nak buat apa? Constructive ataupun destructive interference. So kita tengok sini, kita highlight dulu. Kita nak produce destructive interference. Kita nak buat destructive interference. Okay. We want to do destructive interference. Kelima, baru kita dapatkan equation using cross pair. Using our cross pair method. Our cross pair. Okay. So kita pergi ikut step ni untuk selesaikan soalan. Okay, mana? Ni. So, very starting thin film kita tu letak dalam udara. So, kita sketchingkan dia lah. This is our thin film. Okay, this is our thin film. 1.35, we put it in A. So, atas mesti 1, bawah pun 1 lah. Sebab kita letak dalam udara. So, cahaya akan reflect dekat top surface, forming ray 1. Sebahagian masuk dalam thin film, reflect dekat bottom, forming ray 2. Okay, so visualize dah. Then kita tanya diri, ada tak phase change? So ray 1 reflect bila kita travel dari less dense kepada denser, 1 to 1.35. Less than to denser. So kita ada pi phase change. Ray 2 kita reflect dekat sini. Bila kita travel dari 1.35 to 1, denser to less dense. So no phase change. So kita tengok kita ada perbezaan sebanyak pi. So this is an anti-phase coherent source. So kita kena pasti these two reflected ray is anti-phase. Then we want to do destructive. Kita want to do destructive interference. Then kita pun tengok, saya ada formula ni. Soalan bagi saya formula. Saya tahu dua formula ni. 74 and 75. 2nt equal to m lambda. 2nt equal to m plus half lambda. Tapi mana satu nak guna? Which one? Macam mana kita nak tentukan which one kita nak guna untuk situasi soalan ni? Itu pentingnya kita gunakan cross pair. So kita lukis cross pair kita dekat tepi untuk kita identify. So constructive, destructive, constructive, destructive. Kita ada in phase, kita ada anti phase. Kita ada 2nt equal to m lambda. Kita ada 2nt equal to m plus half lambda. Okay. So soalan ni nak apa? Kita tengok. Soalan ni anti-phase. Dan kita nak destructive. So kita nak destructive, kita jumpalah equation ni. See? Soalan equation yang kita pilih adalah 2nt equal to m lambda. Dan tinggal masukkan nilai. Refractive index 1.35. So kita nak cari minimum thickness. Kita tahu order number kita start kosong. 1, 2, 3 dan seterusnya. Tapi kita tak boleh ganti kosong. Kenapa? Sebab bila kita ganti kosong, jawapan kita jadi kosong. Kita dah tak ada thickness. So tak boleh. So untuk situasi ni kita ganti 1. Okay? For the minimum thickness. Then we get our minimum thickness is 244 nanometer. Okay? So we solve one question. Then we go for the second question. We still visualize our thin film. This is our thin film, but now is acting as coating on glass surface. So bawah ni adalah glass. Coating kan? Coating maksudnya kita tampar dekat atas. So we have 1.35. So glass. How much is the refractive index for the glass? So the question difference, oh 1.5. So the plus is 1.5. So atas mesti A, macam teacher beritahu you. Kita manusia, semua orang hidup dalam udara. So lapisan paling atas mesti A. So cahaya dipantulkan dekat sini, refracted ray number 1. So dipantulkan bila kita gerak dari less than to denser. 1.0 ke 1.35, less than to denser. So ada pi phase change. Sebahagian masuk ke dalam, dipantulkan dekat sini. So dekat sini kita gerak dari less than to denser. 1.35 less than, pergi denser 1.5. So kita ada pi phase change. So pi beza dia adalah kosong. So dia adalah in phase. So now the ray is in phase. In phase, then kita masih nak buat destructive. Kita masih nak buat destructive interference. So kita guna cross pair lah. Teacher tak lukis balik cross pair ni teacher guna balik. So in phase, then kita nak buat destructive. Kita jumpa formula ni. Okay? Yang warna kuning ni. So kita ada 2nt equal to m plus half lambda. So our m masih start from 0. 1, 2, 3. Okay, this time we have to substitute m equal to 0 lah. Because bila kita substitute 0, kita masih ada setengah. So nilai tu tidak akan jadi kosong. So minimum thickness kita pilih kosong. Kita ganti kosong. Okay, so we get our minimum thickness is 122 nanometer. Okay, so we have 4 marks dekat situ. Done with the thin film. Then we move on. Question B. Question B, we have a young double slit experiment. The slit separation is 0.03 centimeters. So we have a double slit experiment, S1, S2. So the separation between the slit is 0.03 centimeter. And the distance of the double slit to the screen is 160 centimeter is 1.6 meter lah. Change it to meter. Centimeter change to meter. Centimeter change to meter. Or calculation in SI unit. Okay, calculation in SI unit. So negative 2 meter. So when a green light is used, the distance of the first bright fringe from the central maximum is 0.3 meter. Okay, when I use a green light, so kita tukar color. Green light, where is green light? Yes, this is green light. When I use green light, I find out that this is the center. Sorry. Terlalu halus, teacher tak nampak. Okay, so if this is our center, so if this is our center line, this is center. So we find out that our first bright, berapa jauh dari center? Soalan kata, our distance of first bright fringe from the center is 0.3 centimeter. So the distance of the first bright from the center, YM, adalah 0.3 centimeter. Okay, so the question asks us to find the wavelength of green light. So we want to find what is the wavelength for this green light. So kita tahu distance from the center. So kita terus guna formula YM lah. YM is m lambda d over d. Bright kan? Bright maksudnya konstruktif. So kalau konstruktif, kita kena guna formula untuk konstruktif lah. M lambda d over d. So our m is 1 lah. Our m is 1. Why? Because even though our m is start from 0, tapi kita bear in mind, 0 adalah untuk center bright. Center bright. 1 baru first bright. So first bright m kita 1. So gantikan, then you will get the wavelength lah, 5.625 to the power of negative 7. So gantian 1 markah, jawapan unit 1 markah. Okay, then second question. Calculate the distance of third dark fringe. Kita nak cari pula distance of third dark fringe from the center. So kita masih guna YM. Tetapi sekarang ni kita nak cari dark. Kalau dark, kita mesti guna syarat M plus half lah. Lambda D over D. Okay? So syarat kita jadi M plus half. Kalau bright kita ada YM is M lambda D over D. Okay, so sekarang kita nak dark become M plus half lah. Okay, so kita guna formula tu. So YM is M plus half lambda D over D. Our M is 2. YM is 2. Kita boleh bilang M start from 0, 2, 3, 4, 5 and so forth. Tapi class, for double slit, we do not have center dark. So 0 is for first dark. 1 is for second dark. So 2 is for third dark. So our third dark is 2. M is 2. So kita gantikan dan kita dapat YM kita adalah 0.75 cm lah. The distance of third dark from the center. Okay. Dan we have the last question for question 7. Explain the change in the interference pattern if the screen is moved further from the slit. Okay, screen kita ni kasih jauh. Okay, dari starting screen duduk 1.6 meter. Sekarang kita anjakkan screen ni, kasih pergi belakang, jauh lagi. So D kita increase. So the question asks you, what happened to the interference pattern? Change in interference pattern. Kalau you refer kepada nota, kalau you nak cerita change in interference pattern, you tengok kepada fringe separation, delta Y. Delta Y is lambda D over D. Okay, so our delta Y is proportional to the distance from the screen. Distance from the screen. So our screen is become further or farther from the slit. It's not further, farther. Makin jauh, farther from the screen, farther from the screen. So our D increase, so our delta Y increase lah. So it means that our pattern will become broader lah. So we refer to delta Y for the change in the pattern. So delta Y is lambda D over D. So our delta Y is proportional to D. This is the concept we use. So our fringe separation delta Y increase. Okay, or you might say our pattern, our fringe become broader lah. Dia jadi lebih luas. Maksudnya kalau initially dia ialah macam ni, kalau very starting dia macam ni, dia jadi dia macam ni. Ini yang very starting bila you punya separation adalah 1.6 meter lah. Kalau you increase you punya separation, dan jarak antara setiap fringes ni jadi lebih besar, so dia mungkin macam ni. Your delta Y become greater lah. Delta Y you jadi besar. Ini very starting, delta Y you kecil je. Okay, so the fringe separation become increased. Okay, so the total mark for this topic is 10 lah. This topic is 10.